Today we are going to continue talking about set operations with Venn diagrams and then introduce De Morgan's laws. Last class we saw Venn diagrams for a few simple operations. Today what we're going to do is we're going to extend those operations to more complex sets. For instance, I could say, use a Venn diagram to shade in A complement intersect B complement. What this means is that we're looking for the intersection of the set A complement and the set B complement. Before we can find their intersection, we have to first understand what those sets are. So if we draw a Venn diagram that represents A complement, again this is everything outside of A, we would shade in everything outside of A in red, or blue, or whatever color you happen to have. I now want to shade in B complement, so B complement is everything outside of B, which I'll do in green. And now I want to look at their intersection. So this is what shaded region they have in common, meaning the intersection will be where I have both green and red. We can clean this picture up a bit and represent A complement intersect B complement in the following way. Next, let's look at A complement intersect B, or union B complement. This is pretty similar, except instead of taking the intersection of the two sets, I want to look at the union, which is combining the two regions. We'll begin by shading in A complement. Next, we will shade in B complement. And now, because we want to take the union, we want anything that's shaded in either color. So let's clean this up a bit and color in the following. Alright, let's do one more example. Let's draw the complement of A intersect B. So just because we're doing operations with sets doesn't mean that we don't have to abide by operations, like order of operations, PEMDAS. In PEMDAS, we always have to take care of the stuff in the parentheses first. So the stuff in the parentheses is A intersect B. Once I find A intersect B, then I take the complement. Alright, we actually happen to have an easy example of A intersect B. This was one of the examples from last class. Now that I know what A intersect B is, I want to shade in everything that's not in that set, because I'm looking at the complement of that set. So therefore, I shade in everything except that violet. Alright, let's do one more example. Let's draw the complement of A union B. So again, order of operations says first find A union B. This happens to be one of the easy examples from last time as well. And now that we're looking at the complement of this set, I don't want to take A union B, I want to shade in everything else. So therefore, I shade in everything except those two circles. And I've just drawn for you the complement of A union B. If you go back and look at those slides, you'll notice that the complement of A union B has the same shaded region as A complement intersect B complement. And the complement of A intersect B has the same shaded region as A complement union B complement. And this turns out to be De Morgan's laws. De Morgan's laws just gives us a way to associate when, how to sort of in a way distribute the complement sign. Alright, let's do a little bit of a harder example. This is an example where we want to shade in a Venn diagram with three sets. Alright, so we have A union the complement of B minus C. So if we focus on sort of the smallest part here, we need to first find B minus C. Once we find B minus C, we can then take its complement, and then once we have that complement, we can then union that with A. Alright, so let's start by finding B minus C. B minus C is everything in B that is not in C, so we shade in that corresponding region. And if I take the complement, I shade everything that's not in the original B minus C. Okay, so right now what we have is we have B minus C complement. We want to union that with A, so we shade in A, and because we're looking at the union, we want to take everything that's shaded in either color, and that gives us the following region. We have just shaded in the set A union the complement of B minus C. Okay, let's do another example. Let's look at the complement of A union B intersect with B union C. Now, this looks pretty confusing and a little bit difficult, but remember, if we start with the smaller sets and work outwards, it makes our life a little bit easier. So before I look at this whole big problem, what I'm going to say is, hey, I need to find A union B, and I need to take its complement. Well, it turns out that we actually already did this in the beginning of these slides today. And I also need to find B union C. So now that I have found these two sets, I want to look at the intersection of these two sets, meaning what shaded region do they have in common? If you look at these two shaded regions, you can see the only part that's shaded in both red and in green is the region below in black. Therefore, we just found A union B complement intersected with the set B union C. Okay, so these are a few examples of how to shade in Venn diagrams. You'll get better with practice, and please go through and pause the slides when necessary. These do take a while to draw, so be patient and have fun.